Our experiment, or rather problem, is to determine the difference of electric potential along the wire, which is actually given in this 1 centimeter wire. It is 1.5 volts, and that, as we said, is the difference between the electric potential at the point B and point A, which are either end of the wire. So we must determine which end of the wire is at the higher potential and what the magnitude and direction of the electric field be inside the wire is. Right, so first off, to determine the spot of the higher potential, a positive difference would indicate that our the point of higher electric potential is at point. And the reason for this is as we saw, if we rearrange the equation here, VB minus V sub A equals 1.5 volts, we end up with an equation the electric potential at B equals the electric potential at A plus 1.5 volts, which would designate, for example, if we were looking at this from the perspective of B and A being nodes of the battery, B being the positive node of the battery, and A being the negative node. Now, of course, this deems for us is that since we've designated electricity to flow higher, an area of higher electric potential to an area of lower potential, our direction is left. So if you guys watch my cursor, just that way, yeah, you know what I mean. Yes, there we go. Now the more difficult aspect, though, is calculating the magnitude of the field. So our steps for doing this were first something which we had to calculate the charge. Uh, sorry, the electric potential. Sorry, yes. So we're getting the electric potential to calculate the charge, assuming that the electric potential at point A was 0, so that we end up with a system where um, the difference in electric potential was indeed the electric potential at B. So this gave us an equation rearranging the equation for electric potential as charge over 4 pi, the electric constant, R, to the charge being 4 pi, electrical constant, R, electric potential, which would be 4 pi, 8.854 times 10 to the negative 12, that's the electric constant, times 0.015 meters, 1.5 centimeters, times 1.5 volts, which gave us a charge of 2.503 times 10 to the negative 12 ohms. Now, if we use that in the equation to find the electric field magnitude, which is indeed constant times charge over the radius squared, the distance, um, end up with 8.98755 times 10 to the 9th times 2.503 times 10 to the negative 12. C over 0.015 meters squared